next challenge is entitled Check if a number is a palindrome. Create a function that returns true if a number is a palindrome. And you probably remember that term with our work with strings. Palindromes read the same forwards and backwards. The notes say that essentially that a palindrome is a number that remains the same when reversed. And there's a bonus: try solving this without turning the number into a string. Since we've already solved this problem with strings and I like bonus challenges, I'm going to do that method where I don't convert to strings. If you want to, that's fine. Feel free to do that. We'll go over the examples quickly just in case. You can see the first example, 838, reads the same as if you go from the back, 838. But the second does not. The first number is a 4 here, and if you read from the back, it starts with a 3. Those are clearly different. And if you look at the final example, 4 matches with 4, 4 matches to 4, and 3 matches to 3. You can read this from the forward or from reverse, and it's the same number. So I think we're good there. We'll go over to code. Please pause the video and implement this yourself. Come back whenever you're ready. I'm going to bring in the system namespace so I can print log statements to help make this clear. I'm going to start with a bad case where the input's negative. I'm going to say simply return. Right? It's not going to read the same from the reverse if we introduce a negative symbol into the mix. Yeah, that just is sort of like gibberish, so we'll call that false. The instructions didn't say to ignore negative symbols or anything like that, so that's the assumption I'm making. Then, to start with, I'll make an integer variable to represent the reversed number, and we'll sort of build this thing in place as we process. Start at 0. And then I also want to take a copy of the original input because I'm going to be modifying that value. And I still want to maintain a reference to that original value and not lose it during processing. So I'll just make a copy for that purpose. Then I'm going to make a while loop, and we're going to do, we're going to start with the original value, right? And while it's greater than 0, it's a positive number, we know, since we got to this point. We're going to process it at each stage, and we're essentially going to pull a digit off one at a time and construct this reversed number out of it. And we've done that in previous challenges. You know that we can basically get the ones place at the least significant digit with the modulo operator, right? You imagine the input 123. If we go modulo 10, it's going to give us that remainder of 3 back. It's going to do 123 divided by 10 is 12, remainder 3, and we get the 3. And then, of course, we have to update our num copy every iteration, right? So we don't end up in an infinite loop. And if we divide the value by 10 each time, that's going to pull a digit off. 123 divided by 10 in integer arithmetic leaves you with 12. The 3 is just discarded, right? We know that. So we have a copy there. Num copy gets updated, and that will get us through the loop. Then we're going to sort of construct this reversed num. Each time through the loop, we're going to multiply by 10, and this won't do anything to start, right, because it's at 0. Anything times 0 is 0, but we'll see how in subsequent iterations this will sort of shift the number that we entered to the left and make room in the ones place to accept a new digit. And then to accept that new digit, we're going to add something to the ones place. And we're going to say num copy modulo 10. Like I said, that modulo 10 pulls off the ones place digit and gives it to us. Modulo 10 ensures that it is a single digit. It won't overflow the ones place. So if we add it to reverse number, it'll now occupy that ones place, the least significant digit. this previous statement times equal 10 already moved the previous value over to the left, and so it won't get overwritten when we do this addition. Hopefully that makes sense. So you can see it's shifting and then adding a new value in the ones place. Then the next time through it'll multiply 10 again, pushing everything to the left, and you keep adding to that ones place. And then we can, each time through, add a log statement so you can see this thing in action. That should help us visualize the num copy, chopping it down by 10 every time, a factor of 10. That's good. I'll process each digit one at a time, and then finally we can return that reversed num is equal to num, right? And so to think of a simple example, right, imagine the input 123. You come through, num copies 123, reverse num 0 times 10 is 0, but now we're adding the 123 modulo 10, which strips that 3 off the end. So now reverse num is equal to 3, and it should print out 3. We're going to divide by 10, which takes the 123 down to 12, right? You come back up, 12 is greater than 0. We're going to take reverse num, which was 3 from the last iteration, multiply 10 gives us 30. Then in this next statement, we're going to add num copy, which is now 12 modulo 10, returns 2. So reverse number, add 2 to it. Now you have 32. You can kind of see that's the reverse of 123. You come through again, num copy divided by 10, 12 divided by 10 is 1. You get to the top here, you got 1. Reverse num was 32, multiply it by 10, you get 320. Now you take that 1 modulo 10, that returns 1, add it to 320, reverse num is now 321. It'll print that, it'll divide by 10, and then you'll break out of the loop. It'll be 0, num copy will be 0. You come out and you have reverse num would be equal to num. In our case, we had 321 equal to 123. That returns false, right? Those are not equal values. So that's sort of how it works. I hope this becomes clear with these print statements. Why don't we give this a run? Cool, yeah, our tests passed. You know, you can see these building one at a time. You can check the test cases. We had 838, 77, 95, 159. Let's do a false one. Number 4 was false. It was 839. So, fourth example. Here you can see 839. It took the 9, it made 93, and it made 938. That's clearly not equal to 839. But you can see how reverse num is being built in each step through the while loop here. So yeah, there's the bonus way of doing it without converting to string. If you did do that conversion, that's fine too. We know that strings are an array of characters. You can take the array class and reverse that once you've converted the string to an array of characters. And you can call array.reverse on it. And then you can go back to a string and you can compare if those strings are equal, the reversed one versus the original. That's another way. One thing, I'll leave you with a bonus to the bonus. If you want, there's a way you can optimize this such that I'm not completely reversing the numbers. So you can imagine with a palindrome, you only have to process the first half, right? You can stop at the middle point. If it's an odd number of digits, you don't even need the middle number. It matches with itself. Think of the number 1, 2, 3, 2, 1. You don't even need to process the 3 or whatever's in the middle. You just need to make sure the 1, 2 matches from the front and the back. So there's a way you can optimize this a little bit to achieve that, where you stop at the halfway point and do half the cycles. So I'll leave that to you to figure out. It's a nice little bonus. Otherwise, hit me up with questions, comments, solutions, and thanks for watching. We'll see you in the next video.